Okay, so I would like to um, also give you an end exam like model paper by next week. So I will provide that to you. I have already provided the LM in the LMS the past paper that was done last year, last semester. So you can refer that as a supporting material. However, that is only for 2 hour duration. So there will be an additional hour in this paper. So because of that, I will be giving you a model paper for you to have a look at. So in that model paper, so I haven't finalized the model paper yet. I will share with that with you. That model paper will consist of essay questions and also MCQ questions. So if you have any questions related to the exam or anything related to the questions or something, you can let me know. Also, I just want to say that
Recording in progress.
I just want to say that the discussions sample paper discussions are available in my previous tutorial videos. I will share that in the LMS with you. So the discussions that I have made regarding the past paper, and I will share those tutorials with you. So I will make them available in the LMS. So have a look at that if possible. Do you have any questions related to the module? Anything? Because today is the last date. Also, I mean, with related to, the online sessions today is the last date, but I will be having the interactive session this week, and that will be basically used for going on the field visit. So that is another thing. So the field visit. Okay, so I hope to like organize a field visit also, and have it also on this Friday. So that is also there. So actually the thing is the field visit is not finalized yet. I will let you know whether we are really going or not by Thursday. Okay, so I will inform more details on Thursday. Okay. Um, okay, so I have made a request. Actually, it was made yesterday to the Oral Corporation. Earlier, I informed them, but I had to inform them the NIC details of the students. So because of that, it kind of got delayed from my end. So it's my mistake, really. So anyway, like I need the confirmation from them to allow us to go there. So still, I did not get it. So because of that, sometimes the field visit might not happen, unfortunately, but I hope it will happen. So they said they can actually allow us. So I think if it is possible, we will make it work. And I mean, I will organize it, and then I will let you know. So the if it is actually going on, then I will inform you on Thursday. So if you are going to the field visit, I will not be able to provide the transportation medium for you. I think you will just have to directly come to the Migoda, maybe Oral Corporation, if possible. If you have problems with that, just let me know as well. Then we will try to organize things somehow. So apart from that, with regard to the exam, as I mentioned before, I will enable the exam, model paper in the LMS by next week. Okay. So the exam, the past paper is already available in the LMS. The the kind of the discussion sessions I will share with you, which I had done to previous students. So I will share those things in the LMS as well. Okay, so these things I will share with you um, as soon as possible. So with today's class, I would like to start by the point where we stopped last week, which was about the industrial IoT systems, right? So industrial, IoT systems, so IIoT systems. So with related to the industrial IoT systems, we discussed about the basic architecture of the industrial IoT system. And there we discussed that there are like robust sensors and embedded, microcontrolling systems in the industrial IoT systems. So basically, we use a PLC, programmable logic controller, to do the computation and processing of the data. So in there, actually, we got an idea on how the sensor-based PLC system is getting connected to the internet, and how the connectivity between sensor to sensors is established, and sensors to different types of devices and other types of robots, machines can be enabled. That also we kind of got an idea through a visual representation of the network. So the main thing about industrial IoT is that we are enabling connectivity through IoT and other technologies, IoT and, cloud computing, edge computing technologies. So we are actually enabling the industrial operations through IoT technologies. So we are not only collecting data at the local place, but also we are uploading the data and making the data available in the global areas, in the global network. So with all that, what we said was that with industrial IoT, we are enabling connectivity in the industrial facilities, in the industrial manufacturing facilities. We are enabling connectivity. That is a special feature of industrial IoT systems. And these industrial IoT systems, we said that it is based on this industrial 4.0 standard. So 4.0 standard is what enables that feature, connectivity. So with that IIoT system, right, we have something called like technologies that we can add on top of the IIoT. As of now, we have this connected network, which has a collection of sensors, embedded systems, then wireless connectivities, and then from there to the cloud networks, then to a certain device. So all that connectivity is made, and the performance of this kind of IoT network can be further improved using enabling technologies. So there are many technologies that are available in the current world that we can consider for this. So one such kind of technology will be basically AI and ML, which is artificial intelligence and machine learning. So artificial intelligence and machine learning, I believe that you know about these technologies being one of the superpowers of the world by now, which is something applicable not only to IoT, but also in almost all the domains of technology. When we talk about the AI and ML, AI and ML require large amounts of data to work with. So with industrial IoT or IoT scenarios also, we are naturally generating large volumes of data through our sensors. We are sensing systems. We are basically doing sensing at the edge of the IoT network. So all the data that is collected at the sensing level will be uploaded to a certain server. It could be the local server where the edge computing is done, or else it could be the cloud server where the cloud computing is done. All this data have to be managed, and then also we need to take some useful information out of these data. So AI and ML is such a technology that enable us to make some useful predictions about the data that we collect, and enable us to kind of improve the efficiency of the decisions we make in the system. So another thing is that the cyber security enable security of data, enable um, enable us to protect the uh, um, enable to ensure the security. Sorry. So this enable us to enable the security and privacy of the data. There are some other technologies also we can take, for example, edge computing. So if we integrate edge computing to this IoT facilities or manufacturing facilities, we can actually do the computation at the industry environment itself, and then give back the decisions to uh, the devices who are working in the environment. Right, so we can make the decision making process very fast and feedback process very fast if we use edge computing and if we have edge computing. So we can actually increase the efficiency of the local network, and I mean increase the feedback efficiency, or I mean we can give real-time updates to the system. We can enable real-time updates and reduce the latency, actually reduce the latency and reliability of the system, and increase the communication efficiency. Same thing, but that is kind of important in IoT network scenarios. We can enhance the communication reliability also. So it depends on the ability of the edge server to do the computation in a reliable manner. So we can enhance the reliability also. So I will also mention that in here as another factor, apart from the real-time updates, latency, and reliability. Also, we have this ability of uh, uh, adding this data mining technology into the IIoT, which is another kind of enabling technology that we can propose for these network scenarios. Data mining is a technology which enable us to organize large volumes of data and undergoing multiple processes where you will be cleaning the data. You will be cleaning the data means like you will be removing unwanted data from the data samples that you have. I mean, sometimes you might have some data which do not really match with the rest of the data that you collect from the system. So for example, if you have temperature measurements, then if you have like temperature measurements like between a certain range, then suddenly your temperature goes minus or it goes really high, then you know that that's an outlier. That means like it is an unexpected data value, data point, a sample, right? So unexpected data sample suddenly occurring, then you might want to remove it because it doesn't really mean anything to the rest of the data. It could be something that is actually useful, but that data should be consistent then. And then only we can observe that, okay, there is actually something abrupt happening here. So by observing all those things, we can clean the data, then we can prepare the data for data set generation. Data preparation in the proper manner, the data set generation, those things we can do. So with the data mining technology, we can organize large volumes of data, right? So these are some of the technologies that we can add, we can see as enabling technologies of IIoT networks. So enabling technologies are those kind of technologies that we can add on top of the current available technology, which is IIoT, right? So we add these technologies on top of the IIoT technology. Then some challenges also remain with this IIoT, which I think I wanted to discuss. So challenges also remain. So challenges actually, I would go through this briefly. So with related to as with related to I mean normal IoT networks, security and privacy of data is a challenge with IIoT networks as well. Then lack of expertise. Lack of expertise to manage the manage this IIoT networks is a challenge. You know, so the so this so I will write this. So security and privacy of data, and then lack of expertise to implement IIoT network is a challenge, it's a problem. So there are not many people who are expert in this implementation of IIoT networks or systems. So that person has to know how to connect the devices in the proper manner, such that these devices can connect with each other, and also they can upload the data to the cloud server. I mean, in the most optimal manner. So the connectivity must be checked, and the hardware components must be checked, and then any kind of connectivity, like connectivity in the terms of like wireless connectivity or wired connectivity, must be checked. And then we have to also check whether the data is getting uploaded, and whether we can monitor the system from a remote location. All those things have to be monitored, and then all those things have to be checked by these expert people who are going to implement this network. So the lack of expertise is something, a challenge when you are going to implement IIoT network. Also, the cost of implementation also can be taken as one another concern. So if you consider buying the necessary equipments to enable connectivity between the sensors and devices, any other robots or any other devices which are included in this IIoT network. So enabling the new addition of hardware and software to the system is going to cost um, up to some extent. So initially there will be some cost of implementing the system. So that cost will also be one of the challenges. Right. So with that, actually, IIoT section kind of ends. So if you have any questions, you just let me know. I will answer right now. I have a quiz for you. I will share that with you. Okay. Okay. Can you join the quiz? Okay. Shall I start? There's some more to join. We start. So the correct answer is Industrial 3.0 because the Industrial Revolution that uh, introduced the computer systems came with 3.0. So before that, it was done mainly using electricity and other mechanical systems. So with the 2.0, it was electrical and mechanical systems, which basically function the industrial networks and industrial facilities. So in 3.0, the computer systems were added and integrated into the industrial, systems or environment, so that they were able to manage the tasks and operations in the system. Okay, I think yeah. So the correct one is integration of connectivity using IoT and data analytics. The um, So the main feature of 4.0 is addition of that connectivity into the addition of connectivity into the industrial, I mean, industrial scenarios, the factories. So that is the main feature. So fourth one is not correct because expansion of global trade, it is not directly connected with the industrial 4.0 standards. It could be like connected indirectly, but the most correct and clear answer is the integration of connectivity using IoT and data analytics. So the correct answer is use of cloud computing for data storage. It's one of the characteristics of the IIoT. You are integrating the cloud servers into the network. You obtain the data that you collect from the IoT local network, and you remotely monitor the data of that infrastructure. So you can remotely monitor, and even you can remotely control the infrastructure through this technology. So addition of cloud computing is there in this IIoT. Correct answer is the final one. So all the above factors are correct. So you have to select the all of the above as the correct option, because we just talked about the technologies that will enable the performance of the already existing IIoT technology, where you can use this AI and machine learning technologies, then cybersecurity technologies and edge computing technologies to increase the performance even further of the IIoT networks. Okay, so the correct answer is all of the above. So I think that also we just discussed about the challenges. So I think that these reasons are clear, where you have the challenges related to lack of expertise of people and a lack of expertise of technologies, lack of expertise in technology for implementation. Then security and privacy of the data is still a challenge, where you have large amounts of data and securing that data is a challenge. Then cost of implementation also can be one of the challenges. The initial cost of implementation could be higher when you are implementing new hardware components into the already existing systems and already existing products, such that they incorporate the connectivity feature. So I think with that, the quiz is over. So thank you for participating. I will update these marks in the LMS. Okay. So machine learning uh, for IIoT is the section that we are going to discuss next. So machine learning is a technology that enables you to use large volumes of data and learn from the data, improve the performance accuracy over time of a certain application. So when we talk about the IoT and machine learning, um, these IoT networks are having a lot of data. So that is one of the advantages of using machine learning on top of IoT. So since IoT actually produces large volumes of data, we can use that to do the predictions using machine learning. So we can do machine learning predictions using the data that we have. So the machine learning predictions become more accurate with the availability of data. So machine learning predictions become more accurate um, with the availability of large volumes of data. So since IoT generally generates that, through sensors, multiple different sensors, and also all its devices, then IoT can actually create the data sets necessary for machine learning based predictions. So the data available um, can be used for generating adequate data sets and then training, uh, right? Training model, machine learning model can be used for generate can be used for Training ML model, testing, validating and testing that model. So testing a ML model. So what do we mean by all this validating, right? So what do we mean by validating? So that is something that used to find the best fit model. Okay, so in machine learning, we are doing this process, step-by-step process to train and test a machine learning model, um, which can be used for useful tasks. So if you consider like training an IoT network, for example, we have to first like collect data regarding the network. So depending on the application, we need to like decide what is the input data, what is the output data, what are the intermediate data we need to collect, and then we put that all into a certain data set. So by considering different scenarios, we can do some experiments and we can take some experimental data from the network. Okay, so from the network, we can take some experimental data by taking measurements. And then we create a certain data set. And that data set is used for the rest of the tasks, training, validating, and testing the model. So the testing uh, part, training, validating, and testing part will have to be done in a certain manner. So in machine learning, you will learn those things when you are learning those modules. Basically, you will be selecting a certain portion of the data set for training the model. And then after your training, you're checking whether the model that you have chosen is the best fit model. The best fit model, choosing the best fit model is considered as this validating uh, step. So training and validating will be done initially. So first you will be training using certain portion of data. So if you're if you're considering all these training, validating and testing, there will be some certain portions allocated for training separately. For validating, there will be another portion. Then for testing, there will be another portion of data. Okay, so the entire data set is not used for training. Only maybe half of that is used for training. Then 1/4 of that data will be used for validating. Another 1/4 will be used for testing. Something like that. So you will only be using some portions of data for these training, validating, and testing processes. So those are the things related to like how you can train a model um, using machine learning, and also like how you can use the IoT scenarios for creating a data set, and then for training, testing, and validating and testing the model. So specifically related to IoTs, we can actually, implement like machine learning algorithms just as like normally. I mean, by just as normal for a normal application, we can integrate different. We can integrate machine learning algorithms, and there are mainly different like machine learning algorithms that are available, or methods of implementing machine learning. So mainly there are three uh, three learning methods. There are three learning methods that can be used. So for IoT systems also these methods can be used. So one machine learning method or one machine learning technique is this supervised learning technique. And this supervised learning technique will be using labeled data with label for making predictions about the output. Unsupervised learning is another technique, and that one will be using unlabeled data or data with no labels, and that will be used for basically categorization, clustering of data. So, I mean, uh, this this technique is used for situations where you will be clustering a set of data into a certain type. You will be labeling a certain group of data into a certain type. So we will discuss about that further. So under supervised learning, what we are doing is we are using labeled data and we are making some predictions about a feature of some kind. Like we are saying that certain, uh, if we take, for example, if we are doing some image analysis, if you are doing some image analysis, the image contains a cat or image contains a dog, the output will be that the image contains a dog or image contains a cat. Some kind of a decision will be made about the features of the data. So some kind of output decision will be given from this supervised learning. Some kind of a decision will be given from the supervised learning. Third type will be reinforcement learning. Reinforcement learning method. So reinforcement learning is similar to like the other techniques, but in there actually we will be uh, the, doing the learning based on uh, real-time updates. So real-time updates are considered to make predictions in the reinforcement learning technique, and that is very essential for IoT networks which are dynamic. So for like useful for dynamic networks. So these are the kind of main algorithms that can be used under machine learning to implement different tasks. So with regard to these machine learning techniques, I believe that you can learn on your own about these technologies. What I'm concerned about is like how these can be used for IoT applications. Okay, so as I mentioned before, like these are the three technologies that basic techniques that can be used, but there are other versions of these as well. So when we are implementing this, the information that you get out of these models differ with each model. So for supervised learning, as I said, if you use unsupervised learning, you get, you will be able to make some decision regarding the category of data. For example, if some devices in the IoT network devices of the IoT network are located in different regions of the network. Let's say, um, I will try to show that if there are some devices in some area in the network, so if there's some kind of access point in here, that access point will be able to detect the region where the devices are using this unsupervised learning method. So we are considering unsupervised learning method. So if we have unsupervised learning technique, then we are able to make some predictions regarding like the places where the devices are. So, if we have this kind of a situation where the devices are located in like in these areas, so if these small circles are devices, um, this could be region 1 or region A. So the second region could be region B. So if a device is very near to the region A, the unsupervised learning technique will decide that this device will be under region A. It belongs to region A. If that device is closer to region B, then the unsupervised learning method will tell that device belongs to region B. So depending on the location of the devices, the unsupervised learning technique will decide to which group this device belongs to. So likewise, the unsupervised learning technique is about classifying the data, categorizing the data into different categories, right? So for IoT networks, we can do something like this, where we define a certain device to be in a certain region, region A or region B, likewise. So that is one application. And another application where we want reinforcement learning is for dynamic networks, where the devices are dynamically changing their location, right? So this is applicable for applications where you have robots, for example, and then I will take the same diagram in here. So if we have some robots in the network, and if there are some obstacles somewhere in the path, there are some obstacles, let's say some obstacles are there in the path. So in this situation, if there are some robots, let's say these small circles represent robots, the robots want to, let's say, go to the destination at maybe they want to come here. So I will say, so if the robots want to come from this green dot towards this red dot, then the robot needs to identify the obstacles and dynamically change its path such that it reaches the destination. So that decision making has to be dynamically changed based on the obstacles that the robot observes. If the obstacles keep changing with the time, then the robot must be able to adjust its path of traveling. So that dynamic adjustment can be done with using reinforcement learning. So the practical applications of machine learning with IoT can be in different areas and fields of ML plus IoT. So one such application could be used for predictive maintenance. Predictive maintenance means like you're predicting the time at which you need to do maintenance of a system or a machine or a vehicle. So if you like keep monitoring the system's condition over time, then without manually checking the system, you can get notifications from the IoT network that maintenance is required in the system. Apart from that, some other applications consist of applications related to anomaly detection and fault detection. So anomaly detection means like unexpected output detection. So anomaly means like unexpected outputs that could occur. So detecting anomalies in the system is where you are detecting some unexpected outputs from the system. And then you detect some faults as well. Then environmental monitoring, right? Environmental monitoring and control. And control also can be another application. So there are many applications like this. So challenges when using ML could be related to management of data. So controlling the data and making the accurate decision using all the large volumes of data is a challenge. And like maintaining the management of the large volumes of data is a challenge. And when we are increasing the size of the network also, uh, the machine learning model has to be adjusted based on that. So if we increase the scale of the IIoT network or a certain network, IoT network, then that machine learning model accuracy also checked and again, validated if more accuracy is needed. Then security and privacy of the data is also hard to maintain with the large volumes of data available. So when you have large volumes of data with ML applications, you need to also have to like spend a lot on maintaining the security of the data. Then model explainability is a challenge. Explainability means like you sometimes get an accurate output from the system, but you don't know why it happened. You don't know why the ML model is working really fine, why it's accurate. You don't know that. So sometimes you cannot explain what's the hidden workings of the ML algorithm. So because of that, model explainability could be a challenge. The real-time processing can be a challenge because there could be some high delay in the computation. So with that, I would like to conclude the session on machine learning for IoT. And with that, entire like content for the module also can be concluded. So I would like to take your attendance. If possible, please mark your attendance. I will share that.